So today we're doing partial fraction decompositions with distinct linear factors, but with a different method. This method is eliminating factors. And I call this like method 2. It's the second one that I teach. And as I had said previously, sometimes one method is better than the other. This happens to be like a preferred method when working with partial fraction decompositions. That is why it is in your textbook. However, the other method is valid and it does work as well. And sometimes that first method that I went over, which we call matching coefficients, is sometimes easier when it gets to more difficult problems with the quadratic factors. In any case, we're going to do an example with distinct linear factors. We're still on that one. And you're going to notice my example looks exactly like the same as yesterday, but remember we're going to go through the next method. Okay, so we have steps 1, 2, 3 here, and then I continued it over here because when I'm showing the slideshow, I didn't want anyone to not have that first part of step 3. And then we have step 4 and 5. So here we go. In our example, we want to do step 1. And step 1 is the same thing as we had before. We're going to factor the denominator. And let the constants of A and B represent the numerators for our denominators. A couple things. Our constants are always an expression that is linear. Okay, so we have A over x plus 2, it's described as linear. B over x minus 1, it's described as linear. And we always add our fractions because we're combining our fractions together. That is a terrible addition sign, so let me see if I can do a better one there. Change the color. There we go. A little bit better. So that's step 1. And step 2 is the same that I've done before. We multiply by our common denominator. Please make sure you're multiplying this to each fraction. If I multiply it with my first fraction, I'm getting 4x plus 5. If I multiply it by my second fraction, A is going to be multiplied with x minus 1 because this can be factored as x plus 2, x minus 1. I'm sorry, the quantity of x plus 2, quantity of x minus 1. The x plus 2 quantity cancels because they're the same, and that's what's left with A, the quantity of x minus 1, and the third fraction we multiply by our common denominator. And it's left with b times x plus 2. Okay, so from here we have step 3. And this is where it starts to become different. So in step 3 it says find values for x that would eliminate the constants. Okay, so we're pretty much looking over here in this section to see what we can make for x. And so there are 2 constants that we're solving for, so I need 2 x values. Now, over here, x minus 1, if I set that equal to 0 and solve, I get 1. That would make A to be multiplied by 0, and that would eliminate it. That's why it's an eliminating technique. And over here, if I take x plus 2 set equals 0 and solve, I'm going to use x equals negative 2. Okay, we need to use these x values, okay, for this problem. Now there is a note here. If there is absolutely no way to eliminate the constants, choose a value for x. Well, we were able to eliminate the constants. So we didn't need to choose any arbitrary value, like 0 or 10. And I did speak about this note as well. The number of x values you need equals the number of constants you need to solve for. Okay, so if we had another fraction, c, we would need another x value. All right, so let's get to work. So to solve for the constants, okay, as it's mentioned over number 4, let me take that away so you can read number 4. We need to actually plug in these x values. So we're going to do x equals 1 first. So in the expression I have in step 2, wherever I see an x, I'm putting a 1. And so this leaves me at 9 is equal to 3b. So obviously b is 3. And then I'm going to use the x equals negative 2. So wherever I see an x in my expression in step 2, I'm going to put a negative 2. So this leaves me with negative 8 plus 5, so it's negative 3, equals negative 3a, so a is 1. And that is how we can write our partial fraction decomposition. So instead of saying a over x plus 2, we now found it's 1 over x plus 2, and b over x minus 1, it's 3. Whoop, that was supposed to be a plus sign. What's with my plus signs today? There we go. b, which is 3 over x minus 1. Ta-da!